Does everyone hear me? In the back? Cool. All right. Great. Welcome to lecture 4. We looked at your feedback on CMS. We saw that most of you prefer to keep the lecture in class and also do the demos. So we're trying something new out later. So we'd like your feedback after class to see if you like this way better. More details when we actually do the demo. So I'm just going to start with a quick review on what we've gone over so far. So in the second lecture, we learned how to connect our server with our database and how to actually query stuff with our database in our database using SQL. And for our third lecture, we essentially went over relationships. And give me 1 second. I need to go and connect this third. Is that yours or mine? What was that? You? So last lecture we learned about relationships, how to use foreign keys to relate models to different kind of models. We learned about one-to-one relationships, one-to-many relationships, and many-to-many relationships. So as a quick reminder on how these work, this is a one-to-one relationship. We have a user and a profile. If I look at the user table, John has an ID of 10, and then we'll see that John is away because of the foreign key user ID in profile table. And then we also see that Jane has an ID of 20, and we can also see in the profile table there's a user ID and her status is online. For one-to-many, we have an album that has many songs. We'll see that for ID 10, Igor has 2 songs, which are Evequake and I Think. And then the 444 has a song 444 and Moonlight from the IDs. And then a many-to-many has 2 tables, and it also has a join table, which you use to relate entries between both tables. So for the net ID of ABC123, we look inside the join table, we see that there's 2 entries. There's 2 course IDs that this ABC123 student is enrolled in. And then we can look at the course table and we see the corresponding courses. And then you can also do this backwards. Say I want to see which students are enrolled in CS 1110. We can look at the join table. I see that there are 2 users, or 2 students. And then I can go back to the student table and I can get students like that. And if I want to enroll, say, DEF456 into CS 1998, I just have to add an association inside of the join table. So we've been using the SQL, and there are some issues with it. So one issue with SQL is that as your SQL queries get more complex, they become less readable. They are also susceptible to vulnerabilities. We'll go into SQL injections in this lecture. And there are also some runtime exceptions that aren't handled well. So you've come across some issues using SQL, like, for example, if you miss a semicolon, it's very annoying. And it's just not as understandable as if we were using something else that we'll discuss in this class, which are Object Relational Mappings, or ORMs. So take this SQL query, for example. Let's actually decipher what this did, and it's very long, and what this is doing is it's going to give you a list of countries and their respective languages based on, I think it's going to give you the max, the country and the language of the max surface area in that table. So as you can see, this is very unreadable. You're gonna have to spend at least an hour looking through this to understand what it's doing. And this is not what we want. So we want a better solution to take care of complex queries like this. And then, speaking of vulnerabilities, like I said, we're going to go over SQL injections, which is essentially you craft an input to mess up an application using SQL. And it could give access to the database in ways that you don't want to, like, for example, giving unauthorized access to data, and also corrupting and deleting existing data in a database. So let's go over an example of SQL injections with login. So let's say I have an email and a password field and a login button. Say the SQL query that we're running based on this looks like this, where the email is going to be checked over here, and email is equal to $email, and then the password is going to be checked with the password. So for example, if I were to type in abc123@cornell.edu and the password is backend, this is how it would be when you substitute it. And let's say I type this in and there is no email or password associated with that, then it would be false and false. Let's say I got the email right but the password wrong, this is what it would look like, true and false. And if I were to get both the email and the password correct, then it should be true and true, and that should let me log in. So what a SQL injection would look like is, so here, I'll decipher this for you. We have an XXX comma, and that gets substituted here. And then you see that there's some code out there. There's or 1 equals 1, which should evaluate the true, and then there's this dash dash bracket. This is a comment, and this made it so that the comma and the semicolon at the very end get commented out. So this actually puts this into there. You're actually typing in code to mess up the SQL injection, and what this the SQL query, and what this ends up doing is when you evaluate it, the email is false, and so is the password. But because 1 is equal to 1 is true, when false and false gets evaluated, we get false to true, and then we get true. So this would let you log in as a user, and that's not what we want. So this is an example of a vulnerability. I don't think SQLite allows you to do that. I think it takes care of it. But there are some other vulnerabilities that would make using an ORM a much better approach because it has vulnerability protection. So yes, object relational mappings. What are these? So you're using SQL queries right now in your database.py, and what we would like is if we can represent these tables instead of creating a table with SQL and selecting stuff from it. We'd like to represent them abstractly as models, because if I think about a student, I would like to have a model associated with the students, essentially a class, and that makes it easier to predict how this thing is going to work instead of just using raw SQL and trying to get things from a table. So essentially, we want to be able to query and manipulate data using objects because we want to use classes. And we still want to preserve the database and the SQL benefits. So the ORM is not deviating from what we've been doing. What we've been doing is raw SQL. The ORM is essentially an abstraction. And behind the scenes, it's still doing the SQL and managing the database as we want it to. So we still need to use SQLite. And so if we look at this SQL query, what it would be represented as in an ORM is essentially as a class. So instead of having to specify the ID as a primary key and the name and the age as text and integers, we can just have a class and specify a column as an integer, the name column is a string, and the age column is an integer. And the specific ORM that we're going to be using for this class is SQL Alchemy. It's very popular for Python, and it comes in built with a lot of features, and it's going to work very nicely with Flask. And the nice thing about ORMs is, like you saw with that complex query, is much more readable, and everything in Python, so you don't have to parse this SQL query. It's abstract, and you don't need to use any SQL in the representation. You're just using Python functions. And you can use it with other databases. Right now we're using SQLite, but if you learn how to use a different database, say Postgres or MongoDB in the future, then you are able to use SQLite or SQL Alchemy with those databases as well. And it also helps protect against SQL vulnerabilities. While injections are necessarily allowed by SQLite, there are some other vulnerabilities that SQL Alchemy will help you with. There are some issues though, because while there is an abstraction, you might be using more queries than you would like, which leads to lower performance, although you don't really have to worry about this with the apps that you will be making in this class, which aren't too intensive. There's going to be a lot more code compared to using raw SQL because you're going to need to put the boilerplate code for ORMs. You won't be able to, well, there are some ORMs that let you use raw SQL, but with SQL Alchemy, you're not going to be using SQL, so you won't understand the fundamentals of SQL, like we've already taught you that, so you do understand the fundamentals. And you might misuse the library because it might be too abstract, although there is documentation for that, so you'd be able to check it out to make sure you don't misuse it. So, all right, I'll let you present with the demo.
Okay.
Are there any questions before we go to the demo? Yeah?
Were we supposed to have installed that beforehand?
You're fine.
What do you think?
Okay.
So, one thing that we're doing with the demo this time, we're just going to ask that y'all start. All right, so as you can see, this is going to be our app.py. I'll explain what a lot of this code does later. For now, let's focus on this file, because this is where a lot of new stuff is going to be happening. So as you can see, we have added this new import, right? From Flask SQL Alchemy, import SQL Alchemy. This is just importing the kind of boilerplate class that a lot of SQL Alchemy stuff is going to be based on. And you can see we've initialized it. created this DB variable equal to an instance of the SQL Alchemy class. From the lecture, Gonzalo talked about how we're abstracting away various things in SQL. One of those things is a table. So from now on, instead of creating a table, we can really just create a class, and each class will represent a table in our database. So let's create class task to let SQL Alchemy know that this should be connected to the database and isn't just some random Python class. We have to inherit from a class defined by SQL Alchemy. In this case, db.model. And so that says, hey, this is a database model. Make sure that you hook it up to whatever database we're using. Cool. Give me one sec. We also have to give it a table name, right? Like Gonzalo mentioned, this is really just abstracting away SQL that the library is doing behind the scenes. So we want to tell it exactly what to name our table, right? Because it's not going to be able to figure that out just from sniffing around. So we're going to say table name equals task, right? And now we have a variable for SQL Alchemy to access, and it can say, okay, cool. Set the name of the table to whatever we've called it, in this case, task. Like before, we're going to want to have an ID column. But this time, instead of writing some SQL to do it, we're representing tables as classes. So each column is just going to be a field in the class. So we can just say ID equals db.column. And so in this case, it's just saying, hey, take the database, create a column, call it ID. Like in SQL, we have to specify what type this column is. So you can see my autocomplete already trying to tell me that it knows it's supposed to be an integer, right? Because before, IDs are supposed to be integer. The SQL Alchemy class has kind of already created a lot of these types for us, so we should be using those types. So we call db.integer as the first parameter to this constructor. And we also want to let it know that this is our primary key, right? So we're just going to say primary key equals true. And that's just a flag to let it know, hey, this is the main key for this table. The other stuff is pretty similar. So we're going to say, like in the other lectures, we want a description for this task, right? So description is going to be another column in our database. So that's a db.column. And when we were doing SQL, we stored this in various ways. You could say, it's a text, not null. You could say varchar, not null, depending on the flavor of SQL you're using. SQL Alchemy makes things nice for us and says, you can just pretend you're programming normally. db.string, like in most programming languages. In this case, we do want to set nullable to false, right? And that's just another flag, right? So you can kind of see the paradigm here where the first column is, or the first thing we pass into the constructor is the type, and then other things are flags we would have normally used anyways in SQL, now represented as code. Cool. And then lastly, like the other lectures, we're going to have it done. This is pretty similar, db.column. The type is going to be Boolean, so db.boolean, and then, again, nullable equals false. For figuring out what types are available to you, you can find all of that in the SQL Alchemy documentation. So, that's what we do too whenever we want to figure out if we can do something. We just kind of Google it, look through the documentation. Cool. Now, one thing is, when we create one of these tasks, how does it know what values to add to the database, right? We've told it, okay, we want these columns, but how do we actually create something, right? Well, if we're representing tables as classes, a row just has all of the fields in the columns, right? So a row is really analogous to an object in this case, right? An object is an instance of a class. A row is kind of containing all the fields of the table. And if we want to initialize an object that has all of the fields in the class, we use a constructor, right? So we define our init function like we have before, pass in self because this is Python and Python likes weird things. And we're going to use a new paradigm for this lecture that if y'all aren't used to Python might look a little bit weird. ** quargs. Oops. Go away. And ** quargs just says, hey, we don't entirely know what parameters are going to get passed into this, but whatever we do pass into this, make a dictionary out of it, and we'll just access the values as we need them. So it's not super great for making your function readable, because if you're importing this function from another file, then you're like, okay, well, what do I pass in? But if you've documented your code thoroughly enough, Quarks is really nice so that you don't have to pass in like a billion things into a constructor for more complicated, classes. And tables can definitely get complicated. Cool. So we're just going to want to set self.description equal to, I mentioned Quarks as a dictionary, so we'll just say quarks.get description, and then self.done equals quarks.get done. Perfect. Remember, the ID is a primary key, so like the other times, it'll increment for us. Cool. We're also going to want some way to convert this into a JSON response, because Python objects and JSON don't tend to mesh super well. So we're just going to define a function called serialize that'll convert this into a JSON for us. And so this is just going to return an ID mapped to self.id, a description mapped to self.description, and then done mapped to self.done. Okay. Is everyone following so far? Or are there any questions? Cool. Well, like in the other lectures, and we talked about relationships last time, maybe we want to have subtasks of a task, right? How are we going to relate these tables to each other? Well, subtasks is really just another table in our database. So we're going to create it as a class, right? Class subtask. Once again, it's going to inherit from db.model to let it know to connect this to our database. We're going to have to give it a table name, right? Every time we want to do this, we have to tell SQL Alchemy what the table name is. So in this case, table name equals subtask. And then a lot of this stuff is going to get copied over, right? We want ID, we want description, we want done. So I'm just going to use my favorite programming trick called copy-paste. That didn't work. Let's try that again. Control-C. There we go. Cool. There is one difference, though. If you remember from the relationships lecture, the relationship between subtasks and tasks is many to one, right? Because for every task, you could have a bunch of subtasks. And the way we decided to represent that in our SQL tables was adding one more column to the many side of the relationship, representing the one that it was connected to. So let's do that here. Task ID is a new column in our table. It's going to be an integer, right? Because we're storing integers, we're storing IDs as integers. db.integer. But one thing we had to do last time was in SQL, we had to somehow let it know that this was a foreign key, right? SQL Alchemy has support for this too. So instead of, before we pass in any of these other flags, what we're going to want to do is pass in db.foreignKey to let it know this is a foreign key. And we have to let it know what it's referencing, right? From the SQL lecture, you'll remember that we had the foreign key reference and then the name of the table dot the field, right? It's the exact same thing here. We're going to want it to reference the name of the table, so task.id, right? Task is this table name right there. And ID is the name of the variable. It actually constructs the name of the columns based off of the variable names, which is, I think it's pretty cool that it figures all that out. Cool. Bless you. So then what we're going to do is similar to the tasks. We're going to, whenever we create a subtask, we're going to want to pass all this information into it, right? So let's define our init function. Just taking in self and quarks again. Self.description equals quarks.getDescription. Did I spell that right? Yeah. Self.done equals quarks.getDone. And then finally, self.taskID equals quarks.getTaskID. Cool. We're also going to want the serialize function so that we can convert this into, a dictionary to eventually convert back into a JSON. So serialize, self, return, ID, self.id, description, self.description, and then done, self.done, task ID, self.task ID. Cool. You know what would be really nice, though? If from the task, we could get its subtasks, right? That'd be a really convenient thing to have. And we do. All we have to do is add a column in this table called subtasks. I mean, whatever we want to call the column, right? But remember, in SQL, we don't have an extra column for this in the one side of the relationship, right? So we don't want to call this db.column, right? That was the whole point of the relationships lecture. You don't store all of that stuff on the one side. But it is still a relationship. So this time we're using db.relationship. It's pretty much always just what you think it is. And we have to tell it what it's a relationship to. This is where things get a little janky, because the first thing you pass into this function is not the name of the table you're making a relationship with, but the name of the class. I don't know why they decided to do that when making the library, but they did. So when you do db.relationship, we have to do subtask with a capital S, because the name of the table is lowercase, but the name of the class is capitalized. Cool. And then what we're going to do is add this thing called cascade equals delete. Cascade is another SQL flag that essentially says, hey, if you delete a task, I want it to cascade through and delete all of the subtasks as well. That's just a handy thing to do. Cool. Any questions so far? What's up?
Can you give an example of just like, because I'm curious.
Yeah, for sure.
Of using cascade for the method that's like that's not delete. Like, what else would you need to use that for?
Yeah, I think there's cascade update. So if multiple things have similar values that they're storing, you can cascade an update. Or if you're like, for some reason changing an ID, that would need to cascade. The context I've always heard cascades actually used in is deletes. So yeah, you can definitely look more into that. And yeah. Now for the doozy again. Last time, the doozy was many to many. This time, it's still many to many. So let's say, we're making this to-do ask, and we want to categorize our tasks into different things, right? That seems like a nice thing to be able to do. We'll start working on that. We'll create another table in our database for categories. So class category db.model. Table name equals category. All right, similar stuff as before. It's going to need an ID, so that's just db.column, db.integer, primary key. Primary key equals true. Maybe the category wants a description, so db.column, db.string, nullable equals false. And then, just to make it different than the tasks, we can add like a color to the category. So like, if we had a hypothetical front end, it would show different categories as, different colors. Or like maybe blend categories together because this is many to many, so tasks can be in multiple categories. So we're just going to have a color, and that can be also stored as a string. And non-nullable. Cool. So I'll get to how we kind of set up this relationship in a bit. For now, I just want to finish creating the easier stuff in this class, like the init function. So this is going to take in quarks again. Self.description equals quarks.get description. Self.color equals quarks.get color. And then def serialize self return ID self.id description self.description color self.color. Okay. Many to many relationships. Last time, we talked about how we needed an association table or a join table to do this, right? We still are going to need something similar to that in SQL Alchemy. But we don't want to call it a model. Because a model, just as a kind of programming practice thing, it implies that this is storing like actual data that's relevant to some kind of entity. An association table isn't doing that. An association table isn't modeling anything, right? It's just combining things together. But for now, I'll show you some of the syntax. So we're going to want to have tasks as, something to talk about. And like when we were referencing subtasks before, this shouldn't be a column, right? Because we're not actually storing this in the table, but it is a relationship. So we're going to do db.relationship. We want to say what class we're referencing. Again, the class, not the table name. So that's task. Then we have to pass in what's called a secondary. If you remember secondary keys from last lecture, that's where this secondary comes from. So secondary, and what this secondary should be set equal to is whatever association table we end up using. So, let's pretend we've done that already, and just set this equal to association table, and then worry about creating that later. Finally, we're going to want to add another flag called backpopulates. And what backpopulates does, equals categories, is it's going to look inside of this class, and every time you make a new category and associate it with some task, it's going to go back into this task class, look for this field, this categories field, and make sure that they're synced up between each other, right? Because we wouldn't want these two arrays to be getting out of sync with each other. Notably, this field doesn't exist in the task class. So let's go and do that. Categories equals db.relationship category, because that's the class name. Secondary equals association table, because we're using the same table as we would use in the other thing. Backpopulates, and this time is going to backpopulate tasks. Oh, oops, equals. Okay. Questions up to there? Cool. Anything anyone want to point out? What's up?
I have a question.
Yeah.
Could you just go over really quickly again the point of secondary and backpopulates?
Sure. Yeah, for sure. So last lecture we talked about association tables, which help you join different many-to-many relationships together, right? What this is going to help us do is we're not going to have to worry about using the association table as a middleman. We're going to create it, and SQL Alchemy is going to figure out everything else for us. And so all that we're going to have to do is access the categories field of the object, and SQL Alchemy will do the joins for us automatically. So that's why we need to pass in the association table as the secondary, because foreign keys are also known as secondary keys, which is where secondary comes from. Backpopulates is saying, okay, let's say I have a category object, and I want to add a task to that category, right? You would think to, access the tasks, the tasks field, and then append a task to it. But then things might get out of sync, because you append the task here, but it doesn't know that this task got a new category. So backpopulates just says which field it should go back to keep things in sync. Does that make sense?
So, like, if you had A and A, backpopulates B, and then you bind an A to a B, you'll also bind that B to A.
Yeah. Cool. One problem with the code I've written right now, the serialize functions aren't serializing any of the relationships. This is just stored in the database and we're not doing anything with it. So let's just quickly add that. So we're going to have subtasks. And I'm going to use this kind of funky syntax, which is s.serialize for s in subtasks, self.subtasks. Hopefully it's relatively intuitive what that does, but if not, it creates an array, and every element in the array is a serialized subtask. So it's essentially looping through the subtasks, for each subtask calling serialize and appending it to this array. Just some fun Python syntax that you can do it in one line instead of having to actually write out a loop. Yeah, and I'll add categories to this in a bit. For now, let's create the association table. So association, can I spell? There we go. Table equals. And I said I didn't want it to be a model, right? So I probably shouldn't be using this db.model, right, which is a class we know exists. Instead, we're going to use a much simpler kind of thing that SQL Alchemy has created for us called db.table. And db.table takes in a bunch of things for us. It's going to take in what we want the name of this table to be. So we're just going to call it association. I don't know. As a second parameter, we have to pass in some information about structuring. I'm going to say don't worry about this too much and just pass in db.model.metadata. You can look into why on your own time if you'd like. If you don't like, feel free to just take my word for it. And then finally, we need columns, right? So now we pass in the columns. So it's going to be db.column with an n, task ID. Again, this is going to be an integer. And this is slightly different than how we defined columns earlier, right? Over here, we're just passing in the type and then whatever flags we want. Here we pass in the name of the column. And part of the reason for that is in this task class, it could figure out the name from the variable name. We're not working with any variable names here because we're just passing things into a constructor function. So we have to tell it the name, which is task ID. It's going to be an integer. And like what we did in subtask, we're going to want this foreign key. Oops. So it's going to be, what did I do? db.integer, db.foreign key. And this time, we're going to do the normal SQL thing where we take the table name dot the field. So task.id, right? Table name task.id. So when you're doing foreign keys, you do want the table name and not the class name. Cool. Similarly, we're going to have a categories ID column, right? Because that's the whole point of a join table as I write the word task. db.integer, and this is exactly the same, right? Foreign key category.id. 10 minutes? Okay. Missed a comma. Cool. So now all of that's fine. But now, if we try adding stuff to our serialization functions, we're going to run into a problem, right? So if I do tasks, t.serialize for t in tasks, right? self.tasks. And then I come back up to this serialize function and I do categories c.serialize for c in self.categories. Right? Does anyone see a problem with the 2 lines of code I just wrote?
They're mutually recursive.
They are mutually recursive. Right? So what's going to happen is, let's say I call this task serialize function, and it has access to a category. It's going to try serializing the category. The category is going to be like, all right, I got you. It'll try serializing itself, which involves serializing all of its tasks, which involves serializing the categories, which involves serializing the tasks, and so on to infinity until your server runs out of memory and the world implodes. I don't know. Right? The way to avoid this problem is by creating what we're going to call a sub-serialize method with just kind of omitting the things that would cause us problems. So we're going to say def sub-serialize self, and it's going to return all of the things that we want it to return without the thing that we think will screw things up. Lovely. What did I do? Oh, I copied the wrong lines. Oh boy. ID, self.id, description, self.description, and then color, self.color. And so we're going to pass this into our task serialize. So this is going to be calling sub. Similarly, we should make a sub-serialize method for tasks. So def sub-serialize, which is going to return ID, self.id, description, self.description, done, self.done. And I'm sure y'all could think of ways to do this without repeating the lines of code, but s.serialize for s in self.subtasks. I'm running low on time, otherwise I would ask why you think subtasks doesn't cause a problem, but for now, you can think about that on your own time. Cool. So this is the DB file pretty much done, right? We wrote all of our database stuff. Now let's go to the app file. And this I'm really just going to talk y'all through. So what we want to do is import all of that stuff we did from our database file, right? So, like, you know, from DB, import all of this stuff. If you notice in the DB file, we didn't say what our database was stored as. So here we're going to do that. We're going to say our file name is todo.db. And then we have to run some configuration stuff. So this is just kind of setting some parameters for SQL to work with. We have to set SQL Alchemy underscore database URI to be this funky string, which is saying it's going to be SQLite accessing todo.db. We don't want to track modifications because that takes up data unnecessarily. It's essentially saying, hey, every time you edit something, do you want us to keep a record of it? And like, that can be useful sometimes, but we don't want it. SQL Alchemy Echo is a really cool feature to have. What it does is whenever you run any SQL Alchemy commands, it will print out to the console all of the SQL commands that it's running behind the scenes, so you can actually see what it's doing. So, you know, turn it false if it's messing with your debugging, but otherwise it's just kind of cool to look at. You're going to need this db.init app with the app, and that kind of connects the database to the server so that connections won't leak. And then you have to run this create all function, which is just some SQL Alchemy stuff. That will all be provided for you in the starter code for the homework. Cool. Success and failure response are as last time. Cool. Now for some of the different stuff. First, well, for one, this should be tasks. Cool. But you can see that we're running this task.query.all. That's kind of the way to run a select statement in SQL Alchemy. You take the name of the class and you do .query. And then on .query, there's a bunch of different things you can do. They understand that a lot of times you really just want select star, and so they've made a convenient shorthand for us that's just task.query.all. Cool. And so for every task, we're just serializing it. That's going to be our get tasks. Create task, we pretty much do it exactly like we're adding something to Python, right? We just create a new object and we pass in the things we want. Remember that we're using Quarg, so we have to say description equals done equals, and that will convert things into a dictionary for us. Now, like with SQL, we do have to kind of add and save this to the database. With SQL Alchemy, this is running db.session and then .add, and then whatever the new task you created. So that's how you like add something to your Excel sheet instead of just kind of leaving it floating somewhere else. And then you have to save the Excel file so that it's actually added, right? db.session.commit. And the success response is really just serializing the task, right? It's already the JSON dictionary for us, and success dumps it into a JSON. For getting task, you do task.query again, but this time instead of all, we want to get a specific task. So we're going to run .filterby, and that's kind of how you do the where part of the select stuff in SQL. And you're just going to pass in exactly what you would pass in for SQL. ID equals task ID. This time, we don't have to do any of the fiddly nonsense with question marks. We just get to say ID equals task ID, exactly what we would want it to say in the first place. This does return kind of an iterable thing, but we know if we're getting something by an ID, we're only getting one thing. And that is the first thing. So we can just say first, and it'll give us the first thing in this list. Otherwise, you can iterate over this. Cool. Update task is fairly similar. You first get the task that you're trying to update, right? So exactly as we just did. And remember, we're working with these as if they're Python objects. Just update the field in the object, right? Task.done is just whatever the request body's done value is. If you notice, we're passing in done, comma, task.done. .get is a nice thing that lets you add default values. So this is saying, hey, if they didn't pass in a description or they didn't pass in a done value, default it to whatever the value already was, right? Leave it unchanged. 2 minutes? Yeah. Now that we've updated something, we're going to need to save it again. So db.session.commit is how we're saving, exactly like last time. Delete, also pretty simple. You get the task from the database, and then you db.session, right, .delete, and oops, .delete, and then the task. And then since you modified something, you commit it. All of the other stuff is really pretty similar, right? You create a subtask, and then you add it to the session, and that will automatically add it to the task for you, because we've set up the relationships properly. Similarly, oh, and just, you know, we're doing a quick error check here to make sure that the task we're trying to assign it to exists. That's all that this query is for. Finally, when we want to create a category, we get the category, right? In this case, we're getting it based on its description, but we could really be getting it based on anything. We've just decided to use that. If we don't already have a category with this description, we just make a new one, right? It's an object. Category, description equals description, color equals color. Remember, we're treating these like they're lists. So we're just appending the new category to tasks. And because of back populates, it'll fix things up so that the category also has the task appended to it. And finally, we save it. Cool. So I believe if I run Python 3 app filled.py, cool, you can see that it ran the create table commands for us, right? And it tells you what SQL it's running. Now let's go to Postman. Let's try just getting tasks to see if that works. Cool, no tasks, makes sense. I don't know. Stop watching Grease 2. That seems to have added itself to the database. Does it work? It does. And then what was the categories URL? It was tasks, task ID category. Cool. But yeah, that's pretty much everything that we've already been doing before, right? Y'all get how to use routes, y'all get how to use Postman. And that's all the new content for today's lecture. So, seems we're at time. Hope y'all have a good night. What's up?
I might have missed this film like earlier in the course, but does the like completed demo code get uploaded anywhere?
We don't usually, but if you want, we can, I think.
I mean, like for this one, since you told us to just watch instead of coding along, I think it might be useful.
Sure, I think. Cool.
So is SQL optimally like something else you have to install, or is it just like import?
Yeah, so you add it to your requirements.txt usually. I think the file we're going to give you should have it already.
Okay, so you don't have to install anything?
You'll have to install the requirements.txt like normal.
Oh, okay.
Yeah. Yeah, stop recording.